Hi, welcome back. Another AI application demo. Today I'm going to talk a little bit about how to create and build agentic AI application with Java. Specifically, you're going to use MCP model context protocol. So let me really talk about and explain what MCP is. So you imagine that a lot of models and then your AI application, multiple AI application and multiple models. How do you communicate among others? Because each model has different specification and API and format. Your AI application have probably some different program language for implementation, like Java, JavaScript, and Python, and .NET, and so on. There's some need to standards communication between AI models and the AI applications. Just imagine that you have your own machine like a laptop and you have multiple external devices to plug in your laptop with so many different ports. For example, like a HDMI format and socket and audio system and USB, USB-C. If you could have one standard port to plug in and out multiple resources, multiple devices in your machine, that'd be awesome. So MCP basically it's an open protocol and project invented by Entropy. It allows the developer to communicate multiple LLMs with multiple different format applications. So here's demo architecture. I'm going to use Quarkus application compared to other like a program language like a Python, JavaScript, even Spring Boot. So Quarkus gives some like a compilation model pattern, which he allows the developer doesn't need to spend time develop some MCP wrapper classes or some of the implementation on your Java code. Instead, you can just specify and define and which MCP server you're going to consume like external MCP services, which is already existing out there. More than 100 MCP servers out there, like a reference to MCP server, integration, and third party, and so on. And you can also build your own MCP server with the Quarkus. It's pretty much easier. So I'm going to use my Quarkus application, develop new AI infused application, specifically agentic application with a multiple MCP server, which communicated multiple external services here. You can find all source code here, Daniel30 Gippo, Quarkus Agentic MCP. Alrighty, I'm going to use Quarkus CLI to create a new agentic AI application. Using Quarkus CLI, create the app, and Quarkus MCP, my project name. I'm going to really add some required extension. First of all, I'm going to use the model on OpenAI. That's exactly I want to use RunChain4j OpenAI extension. And RunChain4j MCP extension, which is I'm going to create a new agentic app and a Borax HTTP for like a dev UI, access some UI stuff. Okay, it automatically generates some file, like a configuration, Docker file, and some skeleton and so on. So when I open my IDE, and you can see pretty much empty project here, just read file and Palm Excel. Let me try to change the Java version first, which I'm going to use 24 by default here. And as you can see, there are a few dependency already pulled on my local machine. The first for the MCP and OpenAI. Okay, so I'm going to create a new AI services, let's say name interface, like agents. So you just add one annotation REST AI services, which allows your plain normal interface. It's just like a AI services with that. Okay, I'm going to create a new one Java method, like a method named agents. And then I'm going to just pass down a user prompt as a username annotation, like a question. And then here's a super important part. How do I make this my application more agentic way? So I'm going to set up some system message. It's an initial prompt. Send it to my LLM to define some scope, behavior, my LLM. So most important part, I want to say you are a professional assistant executing tasks as required. And these instructions are automatically active for all conversation, and all available tools should be utilized as needed without any requiring like a explicit activation. This is the secret source when you create agentic application with the Quarkus and MCP integration as part of the Quarkus extension. So basically, you can define several tools using RAG or function calling, whatever you call that. But that is a pre-defined workload. So you're going to go to LLM and then back to some of your tool and then go back again LLM. You can actually automatically define the flow. However, the MCP, you just let you just let LLM know, hey, you have multiple tools here, like all available tools should be utilized. But you don't decide which tool gonna be invoked first by LLM. LLM will decide based on the user prompt. And then the user prompt keep updating and change there whenever whenever LLM connect to and consume tools. That's exactly autonomous way rather than predefined workflow. Okay, that's it. That's all I have for my Java uh, AI application. And now I'm going to set up some MCP configuration here. This is exactly what I mentioned earlier, the configuration model pattern or practices programming method. This is a Quarkus way. So whenever you're using MCP, you can actually use multiple program languages like Java, Python, JavaScript, or among others. In order to use the MCP and implement MCP, you need to some kind of wrapper class like a Python or a Java or some other stuff. How do you call external or some on-prem MCP server from your client? With Quarkus, you don't need to do anything on your code except for like some of the prompt stuff. And then configuration, just you only thing you needed to do. So let's take a look at a little bit detail. Here I'm going to specify MCP server for memory because you don't need to keep call external services. However, try to remember like original thinking, what you ask, what do you ask, or something like that. And then another MCP server, Google Maps, because I'm going to ask something, recommendation for a fancy restaurant, and you need to make sure it's close by my place. And then private search, like an open source web search, and then select channel, select application, which I wanted to send this whole some recommendation from my question to send it to my specific select channel to share with my team. Okay, a few things. You're gonna add more, whatever you want. And then one more thing, I need to specify which AI platform I'm gonna use for model. So I'm gonna using OpenAI, just a model GPT-4 mini, and then try to set like a temperature, like a specification between accuracy and creativity. And of course, I need to set like a low request response to make sure LLM calls some of the tools in my MCP servers. Alrighty, and now I'm going to run Quarkus demo, give it some live coding capability. I don't need to change it. Whenever I change some code, it automatically recompile, rebuild, restart behind the scene. So this is my activity monitor on my Mac OS. You can see when I search for npm like a Node.js, and you don't see anything because npm, this command line, when I run the MCP server, Quarkus automatically start the MCP server as a sub process on my local machine. So it's currently nothing. So when I invoke the chatbot, it automatically starts the server process. I'm gonna return in the show that. Okay, so this is my Quarkus dev UI, and you can see I define the system message. You can change it from here, even if you don't need to change the application code. This is the beauty of the Quarkus dev mode to verify your functionality for application, specifically AI stuff. And then I'm gonna ask one question. I can find a few good Italian restaurant in Boston, Massachusetts, with a high risk rating. And I don't know. I don't want to go to like a 3.5 less than Google ratings on the restaurant reviews. And in your message, you should include the name and description of the restaurant in detail and driving connection from Back Bay in the Boston area. It's cool, just two sentences. And then when I go back to Quarkus demo, you can have there are a lot of logs request response happening super fast. So I'm going to probably make another video observability for your AI application. Until then, you can just check it out, your logs in the Quarks demo in the terminal window. But also when you go back to dev UI, you can still see the bunch of the logs here. And you go scroll up, and then you can see there are many request response between tools and LLMs. The first tools here, like a Grab Web Search, which is one of the MCP server. And then the other tool, something like Google Maps. So here's a super important thing. I don't even ask to LLM, hey, you need to go to Brave Search first and then back to Google Maps. So LLM autonomously decide which tools the LLM wants to use first and second and next thing. And then when I go back to my running processes, you can see that NPM automatically start up as a server and as a running server process. This is just so cool. So developer is spend a lot of time to set up MCP server and the client, and then implement with the Java application. And now I got some five recommendation Italian restaurant pretty much close from my place. And I'm gonna ask sending this all recommendation details to select channel, specifically lunchtime. Okay, I just actually a typo here, but my AI bot automatically rectified. Okay, you mean the lunchy time, and then you can see that there are a bunch of the logs already there, and the AI said, oh, it will return. Oh, there are. And then when I go back to Slack, and then now you can see that I gotta have some new result from my AI bot. And then when I click on one of the like Eastern Boston, it's literally I never abandoned. I don't think so, but I probably should someday after, and then you can see that there are 4.5 and a 4.1 Google ratings rather than like a less than 3.0 something. So just key point and the takeaways from this video. When you need to create a new agentic AI application with Java, the Quarkus LangChain and MCP integration, it allows you make it super easy and fast and less code and just define configuration on your properties. It make it automatically auto-wire in the running server process. You can also invoke the remote MCP server as well, or custom server and so on. Pretty much easier to stand up your agentic AI application for the autonomy. Hope you enjoyed this video and thanks for watching. See you next time. Bye now.